they'd obviously detected some kind of intrusion, and we're using a camera system to further investigate it. So the monster had the sock on its back, and the sock was a different texture and color from what the monster fur is like. So this is something that can be handled by an algorithm.
Okay, so we see here is a camera looking at an object and trying to figure out what the object is. It's not clear whether the camera actually automatically recognizes the object or just shows it on the screen. But you can imagine having in similar situation, real situation, having a camera trying to pick out real objects. For example, a camera mounted on a robot that's trying to follow you around will need to recognize a person from the rest of the environment in the space, and that turns out to be a very, very complicated problem. In fact, in the current state of robotics, state of the art in robotics, we can't even build robots at the moment that can just navigate through, say, a field, a park, or a backyard without bumping into things.
The monster was in a special environment, where the camera system wasn't moving around, and the camera system could model the dynamics and the spatial and the appearance characteristics of the environment, so that whenever something that it didn't expect was there, it would be able to do a good, robust job.
So in this clip, what the movie is showing here is that probably the surveillance system in this particular place has some target objects in its mind, and it's looking for this object in the real world scene. In this case, on the body of the particular monster. So this is a very typical problem in actually both in human visual system as well as computer vision. Is a visual search problem, where you already have an idea of which object you have in mind, and then you want to match that concept, you match that idea to the images in front of you, and detect whether this particular object is there or not.
What you can notice in this clip is that the sock is very caricature-like. It's not folded in any way. It's like how a children would draw a sock. And that's a very descriptive picture of a sock, and it's not how you would normally see a sock in the real world. I mean, we wish socks looked like that, So you can certainly, we try to recognize socks using their shape, and I guess in this case, shape is the best, except that it looks very different than the monster. So you could tell something is strange because there's something that's not the fur, but to actually recognize the sock, you'd have to look at the shape.
A typical problem in computer vision that has been addressed in the past is to recognize objects from known views from which we have known examples in the database. In this case, we cannot assume that we have seen this before, and the system has to generalize. This is an incredibly difficult task because of the huge variability in object appearances. If you look at the sock, it may have all different kinds of shapes, all different kinds of colors, it may have different textures. So the image of the sock will be very different in each image you see.
So you could actually follow to some degree what's going on without knowing anything about monsters or socks or fur, just by knowing that that's white and the fur is brown or whatever color it was, and that would be enough. So
you could say, I want to find the sock on the background of the of the bear, or I want to have just the difference, anomaly detection, or have a model of the bear where I know how the fur is. So basically it's really how you specify your problem, and here I think you could use any of these techniques. And then basically, given then what exact information you have in the beginning, you can use of either of them.
So if I put an object on this table, which is marble, so it's got lots of texture on it, and I put an object in there, the computer will have a really hard time figuring out what the object is, because there's lots of things happening in this image, and it doesn't know what to focus on. Whereas if I put it on a nice uniform black background, then you can pick out the object just because it's not black. So one of the challenges of recognizing objects in natural scenes is to actually separate them from their background.
So it said targeting and had some box zooming in. And I guess it's trying to A, detect people, and then B, detect bad people. So this is actually a very active topic. People detection has many applications, military, police, but also more civilian applications. So if they can detect you in front of your video game at home, then you can interact with various sports stars or whatever. So it's very, very difficult because people can do all kinds of things. Like they can wave their hands around and they can have funny poses. So what works right now basically is face detection. So if you look straight at the camera, like I'm trying to do now, then you can make a machine to recognize faces, detect faces within an image, and then maybe say who it is. But if I turn my head to one side, it becomes much harder. And if you then zoom out and try and detect the whole body, that's a very difficult problem because of the articulation effect that I said.
That's the kind of capability that we're just on the verge of being able to implement these days, to be able to figure out which aspects of a scene are people and what they might be doing and where they're located with respect to me. So I think that's kind of technology that a lot of people are interested in being able to have for surveillance, for movie industry, for figuring out what kind of food you like to eat when you go to the movies. So I think we're going to increasingly see that kind of technology playing a unobtrusive role in our daily lives in the not too distant future.
That's a very interesting example because there actually are computers that do this now, and they sort the mail. A lot of the mail is sorted automatically by computer systems that read the address. And it's the same way for checks, bank checks. When you write a check, you give it to your bank, and the bank sends it into a central office, and there it's read by computers that read the amount. And automatically, I built one of those systems, which reads, I think about 10 or 20% of all the checks written in the US is read by a system that I designed, which is based on this idea of copying the brain. It's what people call a neural network that does the job. And it does a little bit what Terminator does here, although probably not as reliably as Terminator would do it in this clip. So recognizing printed writing, which comes in sort of predetermined fonts, is actually a fairly easy problem, which has been solved many years ago. So a good example of this is when you see a check, it has at the bottom it has the account number, and the account number it comes in kind of a funny font, which is used a lot. And actually, it's the same font they use to show the recognized characters by Terminator on its own internal screen, if you wish. That font is designed to be easily recognizable by computers. And the way it's recognized is by templates. So the computer has a set of templates for each of the characters, and it lines up the templates to each of the characters, and if it lines up, then that's the corresponding character. And so when it's faced with a new character that it needs to recognize, it tries all the templates for all the character category from A to Z and 0 to 9, and the one that matches best is the one that's being recognized. That works really well for those fonts. It works sort of well for printed fonts, printed characters, although there can be a lot of variability in printed characters. So the tough problem is handwriting. Recognizing handwriting is a very, very difficult problem for computers, and it's still largely unsolved. Computers can recognize handwritten digits pretty well with very low error rate, which is why machines can read checks pretty easily. The computers have a very hard time recognizing cursive handwriting. So this is longhand handwriting where the letters are not separated, where letters are all linked to each other. And the reason of that is that computers generally are the programs that recognize those characters are generally written so that they can recognize one character at a time. And in a handwritten word, you don't know where the characters are. You have to know which characters are there before you can figure out where they are. So you have to simultaneously figure out where the characters are and recognize them at the same time. And that turns out to be a very challenging problem for computers. In fact, the same problem occurs in speech recognition. So I speak English, you understand English. I speak continuously without pauses between the words, yet you know where the words that I say begin and end. Par contre, si je parle en français, vous avez absolument aucune idée de quand les mots commencent et terminent. I just said that if I speak French, you have absolutely no idea where the words begin or end. That's because you don't know French. Okay, but the cameraman here knows French, so he figured out where the words begin and end. So, so that's an example where knowing what you're trying to recognize helps you. I mean, that's a situation where if you don't know what you're trying to recognize, you can't even figure out where the objects you're trying to recognize are in the image or in the sound.
I need your clothes, your boots, and your motorcycle.
So the thing is, of course, there's no display inside the robot. The robot doesn't need a display, right?
And what was that grid thing that kept moving around?
That was great. Also, the code on the side, there's another part. Earlier in Terminator, there's some 6502 assembly code, which I remember fondly. So this is different because we're trying to depict the thought processes of the robot, and I guess in a sense, this is more about filmmaking, isn't it? They're just so that picture is just a hint to the audience. The question technologically, can he differentiate the motorbike from the background, recognize the motorbike? Sure, does he need to do it? Not really, but it's almost at the level of humans. If you say to humans, do you delineate the motorbike from the background when you recognize it? Well, most humans probably think they do. Probably think they first of all say, oh, that's a motorbike, and then separate from the rest of the scene, and that's part of what I use to test it.
So things that are hard for computers are easy for humans and vice versa.
Things that humans do effortlessly as a 5-year-old, like recognizing objects, like animals, has proved to be very difficult for computers to do. That's
and
surprising
things
and
that
annoying.
are hard for people to do have proved to be really easy for computers to do.
Object recognition obviously is a big field, and within this field of study, there are many aspects of the issues. So let's first talk about what kind of objects you want to be recognizing. So there are, for example, sometimes you want to look for a specific person, for example, your mother, or a specific object, for example, your particular car key. And in vision research, we call this single object recognition or identification. And sometimes you're interested in more abstract level, which is you want to look for categories of objects.
So what's going on here is Terminators come back in time, can't take clothes, I guess, through the time machine. Needs clothes transportation. He's sees this bar with motorcycles out front, and one of the first things that he appears to have done, you can see there's this sort of clicking and drawing of the outline of the motorcycles. So one of the first things that this computer, this robot has done is figured out that these are distinct objects. He's taken his image of the world and determined this is one object, this is another object, this is another object. And at the same time, he's presumably determined that these are motorcycles and therefore useful for what he needs to do.
In the crowded scene, the main character just walked into the bar, nightclub. He was probably searching a person, but to start with, he was checking out all the people. So you see the boundaries drawn of the silhouette of the person, everybody he's looking at. So there is a level of category recognition where he's first trying to detect the category of object, which in this case is a person. So again, we have two layers of recognition here. One is looking for the single person who eventually he has found, versus looking for just people. So in the object recognition domain, there are many issues we have to deal with. Even though, let's say we're looking at a motorbike or looking for a motorbike, there's so many variations in the imagery of a motorbike, in scenes or that you have to deal with as a robot. For example, the motorbike can be under very different lighting. The motorbike could be under bright light, or the motorbike could be in a very dark setting. And so you have to be able to recognize motorbikes, whether it's bright daylight or whether it's very dim. So that's one kind of variation. Another kind of variation is the motorbike. Sometimes you have a front view of a motorbike, sometimes it's at angles. So you have to deal with all this kind of rotation. For example, you in the parking lot, when you search your motorbike, you don't want to approach your motorbike every time in the same angle. You want to be able to recognize it anywhere you are, as long as you see it somehow. So we humans are capable of doing that. Of course, we want to make robots do that too. And in the movie, this robots seem to be able to do that. Another kind of variation we have to deal with is occlusion of bits and pieces of this object. Here you can see this person, the robot, is looking for this motorbike, but it's not. He doesn't see the full silhouette of the motorbike. In fact, part of it is being occluded by, or covered, in other words, by another object. In this case, it's another motorbike, but it doesn't matter. The original part of this object he was looking for is gone. So the challenge here is that once you have seen enough of the visible part of the object, how do you stitch together the parts that are missing?
Clearly, this is as yet fiction.
Absolutely. I mean, first of all, he does that in an instant. We can't even do that, right? And second, things were all moving. He's able to segment out very, very difficult scenes out. Like people, the background was very, very dark, and he can hardly segment it, but yet he could. And he was able to superimpose a 3D model on top of something that's moving. It's I don't know. I mean, it's I guess it's one of the holy grails of structure for motion, deformable structure for motion, but it's probably not very reliable today.
The one with the motorcycle is quite believable given the current state of the technology. Even I think the real time aspect is missing currently in many of the systems, but being able to detect object classes like motorcycles is something which probably can be done with today's technology, or maybe technology which will be available in a couple of years, and the real-time aspect also is not too far off. I would say that the people one is, I think, more far-fetched. Especially, he's recognizing almost all the parts also, because he wants to wear somebody's shoes as well as clothes and things like that. So beard as well as articulated objects and so on. So that's a hard one.
And it would be very amusing to see that movie as it would really be done with current computer vision methods. It'd be some artifactual thing in the outline over here, and something would be misrecognized as a person that was actually something on the wall.
That's true. I mean, you could even try and run some algorithms now and see false positives appearing everywhere. And
yeah.
Yes.
I think what they're showing is a kind of half-assed notion of recognition. He attends to some things, and back comes a label for them. Now, how does he know what to attend to? How does he know... is he not labeling the other things? Does he know that they're not interesting? Does he know that they're not worth labeling? How does he know that? If you think about the exercise... I mean, this is an argument that was going since the mid-'80s as well.
Oh, yeah.
How do you know if you think about recognizing things?
How do you know
gee,
what
I'm
to
going to
try
look
to
at that
recognize?
and recognize that. How do you know what to look at and recognize? It's a notion that doesn't work, or at least has intellectual problems that have escaped us.
It seems like what maybe they've got in mind is you're applying this template and trying it in lots of different places. And of course, that's one of the ways that works very well. But the template is too rigid. This is one of the problems with recognizing motorbikes in general, that yes, they can be occluded, but also maybe the wheels turned round, or there's some variability. It's got a big petrol tank or something. So that's quite a naive approach, and this is one of the problems with recognizing classes, that you can't use such a naive approach.
Yeah.
Well, we maybe say something about what has been successful, why things are starting to work now, and that is bringing ideas from the learning community into computer vision, so that rather than just taking one template and trying it, you learn by taking training examples and find which set of templates work well for recognizing classes.
But I think actually that is not that far from the truth, because really most of the things that we do in human vision, we hallucinate things. For example, when I'm looking at a person sitting in front of me, I can basically predict that he has legs there and shoes and feet and things like this, and it could be, for example, that this person is a mermaid and he has a tail down there. It's possible, but it's extremely unlikely.
Yes.
So in a way, we don't see through occlusions, we don't see through solid objects, but in our minds we can kind of predict what is the most likely thing that could be there, and that becomes what we see in our mind's eye. And I think the vision algorithms right now can more or less do that as almost as good as humans for given objects that are easy, like motorcycles or things like
if you recognize the object, for sure, you believe what the object is. All you need to know is what this object is supposed to look like, and you can complete the missing parts.
I think the vector which is there in computer vision and some of the visualization technologies is in the right direction. I think this is achievable. Yeah, I would say that it's a good thing to dream about.
Excellent. That's exactly the level.
Bye.